Let's take a look at what's new in SOLIDWORKS Simulation 2018. The Stress Hotspot Diagnostic tool was introduced in 2017, and it allowed us to isolate elements of high stress whose adjacent elements were relatively low stress, so essentially where the stress values were significantly different between adjacent elements. This could then be used to give us an idea of where a stress singularity was occurring. We can now confirm if the areas of concern are stress singularities by running the new Stress Singularity Diagnostic tool. So in previous releases, to determine whether we were seeing a stress singularity or a real stress, we would need to refine the mesh in the region of concern and then rerun the study. If the stress values continued to increase, i.e. diverge, we would conclude that we were seeing a singularity. If the stress values stayed at around about the same values, i.e. converged, then we would conclude the stress was real. The Singularity Diagnostics tool essentially goes through that process automatically and reports back the results. We can choose from in the dialog box how much mesh refinement we want and what size the mesh refinement should be. So the system is now telling us that stress singularities have been detected, and if we click on OK, it will tell us where those stress singularities are within our model. We can also plot a convergence graph, which just shows us the values of the stress as the mesh is refined along the edges. So we can see here we have two stresses along the edges which are diverging, indicating that there is a stress singularity. These edges are edge 1 and edge 2 within our model. Taking a closer look at our model, we can see there is a sharp re-entrant corner which is causing the singularity. So all we would need to do here is just add a fillet to remove that sharp edge. A common workflow when working in simulation is to design a part and then test that part using the simulation tools. During that process, you will create fixtures, mesh refinements, apply loads, and so on and so forth. You may then want to take that model and test it in its assembly environment, and you'll go through the process of recreating those fixtures and loads at that level, which can lead to user errors. New within the 2018 release, we can import study features from lower level components. Here I'm going to import study features from this mounting plate, and I can choose to import body types and materials, all connectors and contacts, all fixtures, all external loads, and all mesh controls. In this instance, I'm only interested in bringing through the fixtures. So as I click on import, it imports in the roller slider and the fixed hinge fixtures from the part itself. Pin connectors have seen an update in this release. In previous releases, when creating a pin connector, we could only select a maximum of 2 faces. Now we can select up to 10. Making the job much easier. In 2017, we had the ability to copy a study and change it to a different study type. The options to do this were a little bit hidden away. So what we find in this release is when we copy a study, we're given the options to change it to a different study type at that point. So here, I'll just change it to a linear dynamic study. Finally, depending on the complexity of the simulation, it may take a long time to run. So another handy enhancement is you can now set SOLIDWORKS to email you once a study has been completed. So switching back to the PowerPoint, we see a new stress singularity detection tool, which is part of Hotspot Diagnostics. We can import study features from lower level parts and subassemblies. We've updated pin connectors, so we can now select up to 10 faces, and we have email notifications to let you know when your study is complete. Our next video is on flow simulation.